You know, it's almost impossible to overstate how much we rely on the cloud these days.
Hmm.
Digital transformation isn't just a buzzword. It's really happening, and it's overwhelmingly powered by cloud computing.
Right.
What's really interesting, I think, is seeing how companies are moving towards these super flexible and resilient setups.
Yeah, the hybrid and multi-cloud strategies, they're becoming the norm, aren't they?
Exactly. But all this complexity, it brings its own set of challenges, you know?
Mm.
Especially keeping these intricate environments running smoothly and securely.
It's a fascinating challenge, definitely. The more sophisticated our cloud deployments become, the greater the need for skilled people who can, well, not just understand the tech, but think strategically about how it's used.
Hmm.
We've moved way beyond just like storing data remotely. Now it's about building interconnected systems that actually drive business value.
Yes. And that's precisely what we're diving deep into today. We're looking at the crucial roles, the responsibilities of a cloud architect, specifically in 2025. We've got a great piece from Ed Steller laying out 6 key areas, and we're also going to explore the really interesting ways AI and machine learning are getting tangled up with cloud computing. That's thanks to an insightful article from the World Journal of Advanced Research and Reviews.
Ah, good sources.
So, for you, our listener, the one who wants to get informed quickly, but thoroughly think of this as your shortcut, understanding this critical role and the forces shaping it.
And it's a role that's clearly in high demand. Right,
Mm.
if you look at the bigger picture,
Go on.
the Bureau of Labor Statistics, they're projecting something like 13% growth for computer network architects between 2023 and 2033.
Wow, 13%.
Yeah, around 12,300 job openings each year. So that really highlights just how important understanding the cloud architect role is becoming.
Absolutely. And to really set the stage, there's this quote from Rick van der Meeden, a director at Unica. He talks about good architects knowing cloud,
Hmm.
great architects understanding both cloud and traditional company IT. And then those like spectacular and rare architects who can actually explain how their designs create real business benefit.
Ah, that last part, the business value connection.
Exactly.
Mm.
That seems to be what separates the good from the truly exceptional. Okay, so let's unpack this. What exactly is a cloud architect?
Well, at its core, a cloud architect is an IT pro responsible for basically designing and overseeing an organization's entire cloud strategy.
Okay, designing and overseeing.
Right. And it's not just picking a provider. It involves a whole range of responsibilities. They
Okay.
select the right cloud services for what the business actually needs.
Mm-hmm.
They manage those diverse cloud environments. And crucially, they make sure all these cloud solutions directly line up with the company's overall goals.
So it's not purely technical then. There's a big strategic piece.
Oh, absolutely.
And it sounds like they're not working in a silo either.
No, not at all. It's highly collaborative. They're constantly talking with various teams across the organization.
Which teams?
Development, security, operations, finance, you name it. The goal is to develop cloud infrastructures that aren't just techie, but are scalable for growth, cost-effective, for the budget, and fundamentally secure.
Right, it's a balancing act.
A big one, across several critical areas.
Okay, so let's dive into those 6 crucial rules from Ed Steller. First one, designing scalable cloud infrastructures. We hear scalability all the time, but what does it really mean here?
Well, what's interesting is that scalability in the cloud is more than just like having access to more power when you need it.
Okay.
It's about designing systems that can automatically, efficiently adjust their capacity based on demand. Kind of like your streaming service when a hit show drops. Okay.
Handles the load smoothly.
Exactly, the elasticity. So an architect needs a really solid grasp of concepts like virtualization.
Which is like running multiple virtual machines on one physical one.
Precisely. And the best practices for making sure that scaling happens smoothly and, importantly, securely. You see, training like the Google Cloud Fundamentals course really hammering these foundations.
And it sounds like they're not just drawing diagrams, they're actually using specific tools. The article mentions Google Cloud Services, Compute Engine, Cloud Storage, BigQuery.
Right, they're hands-on. They use services like Compute Engine for the processing power, Cloud Storage for the data, BigQuery for heavy-duty data analysis.
Yeah.
They leverage these to deploy resources smartly and manage them efficiently.
So the infrastructure can handle today and tomorrow without breaking the bank or slowing down.
That's the goal.
Okay, second responsibility. Ensuring data security and compliance. This feels huge, especially with all the breaches we hear about.
It is absolute paramount.
Yeah.
Honestly, the cloud architect is often on the front lines, protecting the organization's crown jewels basically in the cloud.
So what does that involve?
It involves implementing a whole suite of robust security measures. Things like secure access controls, making sure only the right people get in,
Yeah.
strong encryption protocols, scrambling the data so it's useless if intercepted, and continuous monitoring systems watching for anything suspicious.
So it's not a set it and forget it thing.
Definitely not. It's ongoing vigilance. And it's not just the tech side either.
What else?
Compliance. Cloud architects have to ensure they're following a growing list of regulations. Think GDPR in Europe
Data privacy.
and HIPAA in the US for healthcare info. These laws dictate exactly how data must be handled, stored, protected.
So they need to understand the legal and ethical side too.
Absolutely. And translate that into policies and technical controls. Training like Cloud Security Essentials is vital for getting people skilled up in this.
Gotcha. Okay, number 3. Integrating AI and machine learning services. Now this is where it gets really interesting, especially with that second article. How does the architect fit in?
Yeah, this is fascinating. The cloud architect acts as a critical link, really, between the company's AML ambitions and the cloud infrastructure that makes it possible.
The bridge, kinda?
Exactly. They're responsible for selecting the right AI tools and frameworks for the job. Is it a specific ML platform? What kind of computing power is needed to train these complex models?
So they figure out the how.
Right. And they design the workflows for how these models get developed, trained, and actually deployed into production.
So they might not be the data scientists building the models themselves,
Not necessarily, no.
but they're creating the playground, the environment where that work can happen efficiently.
Precisely. They collaborate closely with the data scientists, the developers, making sure the infrastructure can handle the, frankly, often intense demands of AI workloads.
Like needing specialized hardware sometimes.
Could be. Or configuring services just right for AML tasks. The article mentions courses like machine learning on Google Cloud, even tools like ChatGPT as examples of things they might work with or enable others to use.
All aimed at using AI for better decisions.
That's the end game.
Okay, number 4. Facilitating continuous integration and deployment. CI/CD. Sounds like it's all about speed.
Speed and efficiency, yeah. The cloud architect is key in designing and implementing these CI/CD pipelines in the cloud.
Pipelines.
Yeah, think of automated workflows. They take code changes, automatically test them, merge them, and then deploy them to the live environment.
Takes a lot of the manual drudgery out of releasing software.
Exactly. The benefits are huge. Much faster time to market for new features and fixes, and better software quality because of all the automated testing. And for AML, it's crucial for quickly iterating on models, deploying new versions.
Makes sense. Any specific tools mentioned?
Yeah, the article brings up things like Kubernetes for managing containerized applications at scale, and GitLab, which is a popular platform for managing the code and automating these pipelines. Shows the kind of tech they'd be using.
Got it. 5th role, managing hybrid and multi-cloud environments. We touched on this. Seems like it's becoming standard practice.
It absolutely is. What's interesting is that organizations are rarely just using one cloud provider anymore. It's often hybrid, mixing their own stuff with public cloud. Or multi-cloud, using services from AWS, Azure, GCP, maybe others.
And the architect makes it all play nice together.
That's the job, ensuring seamless integration and interoperability between, say, your on-premise data center and multiple clouds. It's complex, but it gives huge flexibility.
Lets you pick the best tool for the job from different providers.
Precisely. Get the best bang for your buck. Training often focuses specifically on managing these diverse cloud assets effectively.
And the 6th crucial responsibility, ensuring availability and resilience. Keeping the lights on, basically.
Yeah, you could say that. It's critical. The architect designs the disaster recovery and business continuity plans.
What does that mean in practice?
Putting systems and processes in place to protect against data loss, service disruptions, whether it's a tech failure, a natural disaster, or increasingly a cyber attack.
And continuous availability is key for real-time stuff.
Absolutely vital, especially with applications crunching data and making decisions on the fly. Skills like risk assessment, crisis response, they're paramount here.
Okay, so those are the 6 big roles. But the Stellar article also mentions essential skills beyond those, like understanding specific platforms, AWS, Azure, GCP. Seems obvious for an architect.
It's foundational, yeah. You need deep knowledge of the major players, their services, strengths, weaknesses to make informed choices.
And networking and security firewalls, encryption, compliance, again, feels essential.
Non-negotiable. You have to understand cloud networking, security best practices, how to configure firewalls, implement encryption properly, and stick to those compliance rules like GDPR and IAP.
Then there's programming and scripting, Python, Java, Go, Bash. Why is that important for an architect? Aren't they mostly designing?
Well, increasingly, automation is key in the cloud. Being able to write scripts to automate tasks, integrate systems using APIs, even build small cloud-native apps. It's a huge efficiency booster. It helps bring their designs to life.
Okay. Infrastructure as code? IAC, Terraform, CloudFormation. That's another one.
Yeah, IAC is a game changer. It lets architects define and deploy infrastructure servers, networks, storage using code.
Makes it automated and repeatable.
And less prone to human error. Essential for managing large, consistent cloud environments.
Big data and storage management makes sense with all the data flying around.
Definitely. Understanding storage options, databases, how to manage and process massive data sets efficiently, really critical.
And DevOps and CI/CD pipelines, we covered CI/CD as a responsibility, so understanding DevOps makes sense.
Right. Architects need to grasp DevOps principles, collaboration between dev and ops, and design those efficient CI/CD pipelines we talked about. Smoother, faster delivery.
Finally, cost management and optimization. Watching the budget, I bet cloud bills can get scary fast.
Oh, absolutely crucial. Costs can easily spiral if not managed. A good architect is constantly optimizing resource use, making sure solutions fit the budget.
So, a really diverse skill set, what does their day-to-day actually look like?
It's pretty varied. They're designing solutions for specific needs, working closely with dev teams on cloud integration, monitoring system performance, implementing security measures, and also keeping an eye on new tech to see how it can improve things. It's a mix of planning, building, managing.
And who are they typically working with? Ed Steller breaks it down. First, the IT department, obvious link there.
Yeah, very close partnership, making sure the cloud strategy aligns with the overall IT infrastructure, modernizing systems, moving workloads. IT relies on their expertise.
Then the development teams building the apps.
Exactly. The architect guides them on using cloud services effectively, optimizing apps, using those CI/CD pipelines, enabling developers, basically.
Security and compliance teams of vital collaboration, sounds like.
Hand in hand. Ensuring deployments meet security policies, legal standards, essential for tackling threats and staying compliant.
The finance department may be less obvious, but crucial for costs.
Absolutely. Making sure solutions are cost-effective, fit the budget. They help evaluate pricing, optimize spending, forecast costs, balancing performance and cost.
And project management, keeping initiatives on track.
Precisely. Coordinating to align cloud work with project timelines, resources, goals, ensures structured adoption, minimizes risks.
Okay, great overview of the role. Now, let's really dig into that intersection with AI and ML, using the other article. How does cloud actually enable AI and ML?
Well, it's a really symbiotic relationship, isn't it? Cloud computing provides the essential infrastructure and the incredible flexibility that AI and ML algorithms absolutely need.
How so?
Think about the sheer volume of data needed to train these models. The cloud offers practically limitless storage.
Right.
And then the massive compute power required, both for training and running the models. Cloud gives you scalable resources on demand. No need for huge upfront hardware investments.
So it provides the scale for data and power.
Exactly. Allows organizations to tackle huge data sets and complex calculations.
And it's not just a one-way street, is it? AI and ML are also improving cloud services themselves.
Absolutely. AI/ML are being baked into cloud services to make them smarter, more efficient. Automating IT tasks, systems learning usage patterns to optimize performance, predictive analytics spotting problems before they happen.
Leading to better resource use, faster responses.
Right. Better efficiency, reliability, performance overall.
The article mentions AI ops, artificial intelligence for IT operations. What's that about?
AI ops is a really interesting field. It's basically using AI and ML to revolutionize IT operations management, especially in these complex cloud environments.
How does it work?
By analyzing the vast amounts of operational data logs, metrics, network data, AI ops aims to automatically spot anomalies, predict failures, and help IT teams make smarter decisions.
So improving efficiency and reliability.
That's the goal. The article even cites some impressive results, like a 15% boost in anomaly detection accuracy and a 50% increase in incident management effectiveness.
Wow, that's significant. And AI is even involved in tuning the infrastructure itself.
Yeah, exactly. AI algorithms are optimizing task scheduling in data centers, which can cut energy use and allocate resources better. The article mentions specific techniques like gated graph convolution networks, and convolutional neural networks.
Okay, technical terms, but the idea is smarter resource allocation.
Right. Intelligently assigning jobs to servers, reducing bottlenecks, lowering costs, making cloud more sustainable and cost-effective.
And AI also helps with detecting and fixing problems, fault detection.
Yes, a critical area. Traditional methods often rely on static rules, which struggle in dynamic cloud environments.
But AI can handle that complexity.
It can process huge amounts of real-time data, spot subtle patterns that might indicate an impending failure. The article mentions using things like sparse denoising autoencoders for this. It makes the infrastructure much more robust.
And of course, security. How is AI bolstering cloud security against threats?
Hugely important role.
Yeah.
AI is crucial for defense against increasingly sophisticated cyber threats. The article discusses AI models for early detection of DDoS attacks.
Distributed denial of service.
Right. Using models like CDAE-KNN, and even for things like cross-site scripting, XSS attacks, using models like CMABLSTM. Table 1 in the article lists various models and the threats they mitigate.
So AI provides advanced defense mechanisms.
Absolutely essential for a strong security posture in the cloud today. For listeners, understanding AI isn't just futuristic stuff, it's fundamental to cloud security now. That's key.
Okay, so massive benefits. But the article also highlights challenges in integrating AML with the cloud. What are the main hurdles?
Well, one big one is just the distributed nature and scale of the cloud. Managing these complex systems, making sense of the data, it needs sophisticated AI.
And keeping data secure across all that.
A major concern. Plus the inherent complexity of AI algorithms, the need for high-performance computing.
Practical issues, too.
Yeah, things like slow internet causing latency, the upfront cost for edge computing setups, and the risk of vendor lock-in with specific cloud AI services.
So not always straightforward. Okay, looking ahead, we have insights from Cloud Computing Trends 2025 and that quantum computing white paper. What key trends should architects focus on for 2025?
The Trends article points to several things. Hybrid cloud is still huge, balancing security and scalability. Understanding how to integrate on-prem and public cloud effectively is critical.
What else?
AI-powered data centers, using AI for optimization, efficiency, security within the data center. Then there's multi-cloud, evolving towards omni-cloud, aiming for more seamless interconnection across providers.
Interesting. Omni-cloud.
Yeah. Cloud edge computing is also growing. For real-time processing needs, intelligent SaaS AI embedded directly in cloud apps, and containerization like Kubernetes remains vital for flexible deployment. Architects need to navigate all this.
And then the big one, quantum computing's impact on cybersecurity from that AFCEA white paper. Sounds potentially game-changing.
It absolutely could be. The paper explains that quantum computers, because they can solve certain problems exponentially faster than classical ones, pose a major threat to current encryption, like RSA. That relies on factoring large numbers being hard.
And quantum computers could make it easy.
Potentially. Estimates suggest they might break current standards, like 2048-bit RSA, within maybe 3 to 5 years.
Wow.
Which leads to this risk of store-then-decrypt attacks. Adversaries grabbing encrypted data now, hoping to break it later with quantum power.
That's concerning. What's the cybersecurity community doing about it?
They're actively working on defenses. The paper highlights post-quantum cryptography, or PQC.
New encryption methods.
Right, designed to resist both classical and quantum attacks. NIST is already working on standardizing PQC algorithms. Another approach is quantum key distribution, QKD, using quantum physics for secure key exchange.
So solutions are being developed.
They are, still evolving, but cloud architects will need to understand and eventually implement these to ensure long-term security.
So it's an incredibly dynamic field. Architects need deep current knowledge, grasp AI's impact, and anticipate future disruptions like quantum.
Exactly. And for you, the learner, understanding all these pieces, the architect's core job, the AML integration, the coming quantum challenge, gives you a real edge in grasping where IT infrastructure and digital transformation are headed.
It really does. It makes you wonder, doesn't it? As cloud gets even more complex, intertwined with AI, ML, maybe quantum, how will that cloud architect role keep adapting to ensure security, efficiency, and, well, innovation? Certainly seems like a space that demands continuous learning, especially areas like post-quantum crypto and the whole ethical side of AI in the cloud. Lots to think about.